Okay, reducing a numerical fraction, 210 over 980. Now, you've probably been taught to do this by using prime factorizations, but you're probably also taught to do it just by finding a number that will divide both of these. Like, we divide both of these by 10, we get 21 over 98, right? And then we can divide 21 and 98 by what? Is there something that will divide both 21 and 98? Well, maybe we'll find it, maybe we won't. Okay, let's, though, use the prime factorizations. Prime factorization 210 is 2 times 3 times 5 times 7. Prime factorization of 980 is 2 times 2 times 5 times 7 times 7. Okay? Let's make sure that's 49. 49 times 5 is 245. 245 doubled is 490, and double that you get 980. I believe that's right. Let's do it again. 2 times 2 is 4. 4 times 5 is 20. 7 times 20 is 140. And 7 times 14 is 98. So 7 times 140 is 980. So that's right. I think. I hope. Capable of mistakes, as you know. Okay. Well, now, you've been taught to cross things out and call that cancellation. I don't allow cancellation in my course. The reason I don't is nobody knows when cancellation applies and when it doesn't, and people there's an epidemic of incorrect cancellation. There's simple expressions I give people that almost everybody will cancel and get the wrong answer because people don't follow up with checking their results. You would learn pretty quickly. So the reality is, in a precalculus class, I can't allow cancellation. So as an alternative to cancellation, I see that I can write this as 2 over 2, because I got a 2 over 2 here, times what? Well, I've got a 5 there and a 5 there, so I can do 5 over 5, and I can do 7 over 7. Okay, so I've taken care of this 2, this 5, and this 7, leaving me only a 3 in the numerator. And I've taken care of the 2 and a 5 and a 7, but there's a 2 and a 7 that aren't left. So that's going to be over 14, and I shouldn't have written it that way. I don't want to skip a step. And now I'm writing the right 5. I can make that into a 3. It's bad looking. It's not a 3. It's a 2 times 7. Okay, let me get it right. I want it to be pretty. Okay, now clearly I can rearrange the fraction like this, because if you multiply a series of fractions, you just multiply all their numerators, multiply all their denominators. And remind you that doesn't work for addition. Which means addition is more complicated than multiplication or division for that matter. Okay, well, 2 over 2, 5 over 5, and 7 over 7 are all equal, each equal to 1. So we have 1 times 1 times 1 times 3 over, all right, 3 over 14. I'll do the multiplication, 2 times 7, and that equals 3 over 14. Okay. Now that's the way to reduce a large fraction. Otherwise, you're just hunting for factors. If the factors are big, you never find them. It's a mess. So any fraction where it's not obvious what to do, this is how it needs to be reduced. And this mimics what you do when you have a fraction involving algebraic expressions. Okay? And it's real important to understand this because polynomials, every polynomial factors. Okay, other algebraic expressions factor. You want to use factorization. It's easy to understand factorization for real numbers under prime factorization, and that makes it easier to deal and to understand the factorizations you have to use to simplify algebraic expressions.